It's a nightmare scenario. You find yourself in a life-threatening situation and you call the number that is supposed to swiftly bring first responders to the rescue, 911. If you call from a landline, dispatchers know exactly where to find you for a fast response time. But if you call from your cell phone, which most of us do nowadays, it's a much more complicated process to figure out where exactly you are. The implications of this could be dire in many 911 situations. Tonight, Alex Gerrish is going to brief us on the locational accuracy of cell phone calls using the E911 system. Here's hoping that he has some positive findings for us. Alex.
Thanks, John. How's my volume back there? You guys hear me okay? All right. My name is Alex Gerrish. I suppose I'm a geographer. And I have a little bit of a background in emergency services and public safety. So this is my first attempt to kind of bring these two worlds together. So I'm going to be talking about 911 tonight. And I wanted to know how accurate the system is and would emergency responders be able to find you when you are in trouble. So here's how it's going to work here. We're going to go over my problem statement, look at the problem in perspective. I'm going to discuss some of the terminology so we can learn a little bit more about how 911 works. We're going to look at the study areas that I used and some of the data sets that I looked at. We're going to look at the spatial analysis methods that I used, the results of those spatial analysis methods, and some conclusions that we can draw from those results. So I'd like to start by asking, how many of you here have had to call 911 before? But a show of hands, most of us. So how many of you, when you called, did you expect that that the 911 operators could basically know exactly where you are? Was it a few? And that's a perfectly reasonable assumption to make in today's society. The cell phones that we have sophisticated GPS technology. Your Netflix app knows where you are. Your Facebook app knows exactly where you are. But the 911 system runs off of very different technology. It was originally optimized for landline networks, like John said. If you were to call 911 from a landline, they would be able to send emergency responders right to where your phone's plugged into the wall. But tracking a caller's location from a cell phone is quite a bit different. And that difference is important because of the prevalence of cell phones today. 82% of emergency calls in Tucson last year were made from cell phones. Does that surprise anybody? I didn't think so. And this is the GPS technology that smartphones in particular use has trouble kind of communicating with the 911 system. E911 wants to use the triangulation of cell towers, maybe a little bit of GPS, but not much, when trying to exact your location when you call. And so the spatial accuracy is in question here because one of the first questions that a 911 operator asks you when you call is, what's your location? Where are you? And sometimes people can't give that information. Sometimes they don't know where they are, or they speak a different language as the operator, or they can't speak at all. So for these situations, spatial accuracy of the system is absolutely paramount. They need to know where you are. And currently, there's no nationwide spatial accuracy standard that is in place. There are proposed standards. The most recent was the one by the FCC last year that said they wanted 50% of your emergency calls to be within 50 meters. So that's what we're going to be looking at tonight. We're going to see if the E911 system here in the city of Tucson is up to that standard there. There's something called Next Generation 911 that's on the horizon. It may be rolled out next year. It might be rolled out farther away. But this one will overhaul the system and will hopefully make it a little easier for the 911 system to communicate with your smartphone GPS. So until Next Gen is rolled out, we know that E911, the existing system here, runs on outdated technology, and we want to find out How accurate is it? Is it within 50 meters 50% of the time? We want to get a sort of baseline spatial accuracy assessment to compare to next-gen 911 when it's rolled out to see how we need to do. We also want to know how useful the E911 confidence radius values are, which is something that I'll introduce in this section here. So there's some terminology we need to understand 911. E911 is just the 911 system with location technology. It supplies the 911 operator with an automatic numbers identifier, or an ANI, and an automatic location identifier, which is an ALI. So the ANI is just your callback number, so the 911 operator can call you back if they need to. And the ALI is what we're going to be looking at in this study here. It comes in two flavors. Phase 1 is just the cell tower. It's generally useless unless you're actually calling from where the cell tower is. Unlikely. Then there's the phase 2. The 911 operator can rebid or retransmit for a better, more accurate sort of guesstimation of your location. That comes in as a phase 2. So phase 2 locations are what we're going to be looking at. And your phase 2 location, which is where you supposedly are, it gets something called a confidence radius or an uncertainty value. And this is a little circle that the system draws around your phase 2 location that represents how confident the system is as to your location. So a larger circle indicates lower spatial accuracy. So you're within this 1 kilometer circle. And a smaller confidence radius represents a higher degree of spatial accuracy. So we want those smaller circles there. And the public safety answering points, we call them PSAPs. There are 4 around here, and these are the people that we're talking to. These are the 911 operators and dispatchers and people who send responders to help you. They are the City of Tucson, Pima County, Marin, and Oro Valley. And that brings us to my study areas and this data. So for this project, I did 2 things. I made field test calls. I went out in the field and I called 911. And I looked at existing 911 call data, so real 911 calls. So here's the study area for these. These are the PSAP boundaries. You can see Tucson there in green, Oro Valley and Marana up there, and then the blue in the background, that would be Pima County. The purple area right there is where we are now. It's a university which is routed through the city of Tucson, so it's basically the city. So those 4 are the ones that we have been dealing with. And what I did was I coordinated with 1 PSAP per week, and I drove out. They gave me a 1-hour window on a Sunday morning when there was fewer real 911 calls, and I took GPS control points with a Trimble Juno 3B, one of our Trimble devices, and took locations at 4 different points throughout the PSAP that I could access within an hour. And I called 911 from a cell phone 3 times. I used a total of 4 phones for this. There were 2 smartphones and 2 dumb phones. There was a Nexus 5X smartphone, that's mine, a Samsung Galaxy I borrowed from a friend, an LG Voyager that I took out of a drawer, charged it, and then called 911 with it, and it's a Samsung R560, which is a great phone. You'll see what this thing can do. So the red triangles up here, that's the GPS locations, and then the green dots there are the phase 2 locations that 911 gave to me. So I called 911 and I requested my phase 2 location information, which was a lot of fun. And my confidence radius value as well. So that was the first part. That was part 1. Part 2 was looking at real 911 call data. So this is 1 year's worth of calls from the city. This came from the Tucson Fire Department Regional Communications Center. They pulled it from the ICAD archives. These are just fire and medical calls. These are just for the City of Tucson PSAP, and these are just cell phone calls. There are 31,000 of them. And so the difference between these points here and then the field test calls that I made is these people didn't have GPS devices. So all these points had was their location and the size of the circle, the confidence radius that was drawn around them. So we're going to see what kind of spatial analysis we can do with these. So my analysis was fairly simple. I did two things for my field test calls. I ran a tool that told me how far away the phase 2 location that 911 said I was from the GPS control point where I knew I was standing. And for the actual 911 calls, I ran a hotspot analysis that let me know where there were really high confidence radius values that were clustered together and where really low ones were clustered together. So this is the first one that I use for my field test calls. It's called the near tool, and it simply takes an input and tells you how far away Euclidean distance that point is from your target. So I put in the phase 2 locations where 911 said that I was here, and then I said how far is that from my GPS location. And the distance that it gave me there, I called my spatial error, which is what I'll be referring to at the rest of this project here. For the real 911 calls, I use something called a hotspot analysis, which uses the Gerrish or GI star or G statistic to determine clustered areas of high values and clustered areas of low values. So this will hopefully show where there are a lot of really good, where there's a lot of really good accuracy and where there's a lot of really bad accuracy. Those little circles there. So take a look at my results for the field test calls first. Here's the graph this way. These are the field test calls that I made. 43 out of the 48 calls connected. The other 5 were very awkward. And the values on the y-axis, that is the spatial error. So that's how far away I was standing from where 911 said that I was, the phase 2 location. So as you can see, there were some outliers here, and they were all from Sprint. And that's because of the phone that I was using, the Samsung R560. It's an old Cricket phone, but it was the most expensive phone that you could buy in 2003. So this one here, I do not know what happened with that one. That was my phone that's in my pocket right now, and I'm convinced that's a spatial error. I could not fix that one. But the big number here is the median value is 9.29 meters. So that is actually very, very good. That's well within the 50-meter proposed standard, and 88% of these were below that. So that was actually pretty good. So then I was thinking, what if we didn't have a GPS control point? What if we just had the uncertainty? So I did the same thing for these, and we had outliers just like we did. The median value is 14 meters, and once again, 88% of these were less than 50 meters. So this is still really good. So then I thought if I get the difference of these two graphs, I get this. And anything above 0, that's how far inside of the confidence radius I was standing. And everything that's negative value, that would be a spot where I was actually outside of the circle where E911 said that I must be. So with the exception of achy breaky here, the rest of these were within the error that I allowed for my GPS device, which was 5 to 10 meters, because that's what they claim those trembles can do. So that one there may have been a problem, but not a huge problem there. So I was a median of 6 meters inside of those confidence radii. So just what a few of these looked like. This is what most of them looked like. This point was actually taken right across the street from the 911 communication center. And as you can see, the triangle where I was standing, that's within the 3 circles there. So that's what a good one looks like. This one's achy breaky. I have no idea how that happened, but it's 770 meters away. This is what that Nexus R560 can do. That's a 500-meter confidence radius. And here's another one that you can effectively see from space here, 1.4 kilometers. So that would be very difficult to find somebody if they couldn't give you their location. So we go to the real 911 calls quickly. Here's a kernel density map that I made to kind of see where most of the calls were made from. And as you can see, they are kind of clustered in the downtown area, kind of South Tucson, and also the the Prince Stone corridor and Grant Alvernon are also very popular areas to call 911. Here's my hotspot analysis map. The blue areas are areas of clustered high accuracy. Those are the good areas. And the red areas are clustered low accuracy. So a whole bunch of really big circles drawn around people's phase 2 locations. So if you can kind of compare this with the density map, with the exception of South Tucson, most of the calls that are made are coming from areas with relatively high spatial accuracy. And here's the distribution of confidence radii for the real 911 calls. As you can see, most of them happen to be 16 meters, and 76% of these are under 50, which is well within the proposed standard, and that is the good news. The left side of the graph is the good news. The right side of the graph is the bad news. There are people who call in and get a 32-kilometer confidence radius. So if somebody calls in and they have a 32-kilometer confidence radius and they can't tell you where they are, they're not going to get found. So we can look at the conclusions we're drawing here. The E911 system impressed me. It works fairly well. It was in the standards. It set the bar fairly high for next generation 911. The uncertainty values we saw were indeed reliable, and more specifically, the newer cell phones, the smartphones performed better, so their GPS had something to do with that. And all these results were outdoors. So maybe a future study could see how the accuracy is when calling from indoors, but for now, according to my data, if you have to call 911, maybe go outside. And this concludes my presentation. Thank you very much. Tim, 4 minutes for questions.
So did you seek any T-Mobile funding for your project?
I did not, but in retrospect, I should have. They're next. Yeah.
So it's okay if you don't have any idea about this, but I had an experience where I called 911 inside, and my Wi-Fi calling was hooked up. Mm-hmm. And I can't remember in that situation if it went through or not, but do you know how Wi-Fi calling might tie into this?
I don't know, but I do know that for one of my semester projects, I looked at the GPS accuracy of smartphones connected and disconnected from Wi-Fi, and they were actually much better when they were disconnected from Wi-Fi, which was interesting enough. Maybe that was just because my wireless testing was on campus, but my results pointed to disconnected being more accurate. But when you call 911, it goes into 911 mode, and with some smartphones, it actually tries to tell 911 system where you are. Like, it tries to communicate some of that GPS data, but there's just not a whole lot of, compatibility in most parts of the country that I read. Sir?
In this research you did you look at or did you learn anything about the next gen 911 system? Do you know if the answer is yes? Do you know what plan is going to be used for the GPS point?
What I know about Next Gen 911 is it's going to put GIS at the front where it belongs. And it will also make it so you can text 911 and you can video call 911, and supposedly it will be able to communicate better with your cell phone. And more GIS, so better. Anybody else?